In this video, we're going to talk about the properties of quadratic functions. We're going to start with a form of a quadratic function called vertex form. Now, we've already discussed the fact that the general form of a quadratic function is f of x is equal to ax squared plus bx plus c. So this is considered general form. What we'd now like to do is transition to a much more useful form, which is considered or called, most of the time anyway, called vertex form. This vertex form is f of x equals a times the quantity x minus h squared plus k. Now this should look pretty familiar considering the fact that we have an h and a k, and we talked about an h and a k when we were dealing with transformations. So h, remember, was your horizontal shift, and k represented your vertical shift. And this is really no different. So for example, let me just take f of x is equal to x squared. And let's go to the graph here. And if you were to graph f of x equals x squared, you'd have these 3 points, and the shape of the graph would be a parabola. And remember, with h and k, we are horizontally and vertically shifting. Notice also one very important point, in fact the most important point on the parabola is this point right here, and I'll in fact circle it here in green. That point is called the vertex. That point is always going to be the highest or lowest point on the graph with your parabola. Because it is the point at which the graph is transitioning from increasing to decreasing or decreasing to increasing depending on your parabola. So it's a very, very important point, and notice it's located on the origin 0, 0. Well, when you have h and k involved, all of a sudden you are shifting the whole parabola horizontally and vertically, including the vertex. And since the vertex is originally on 0, 0, the vertex then becomes wherever h and k is. So for example, if I have f of x is equal to x minus 2 quantity squared plus 1, you're moving each and every point to the right 2 units, up 1 unit, including the vertex, which means now the vertex is the ordered pair 2, 1. So this is vertex form where h, k is the vertex. With the first problem, I'm going to take this function, which is written in general form, and try to convert it over to vertex form. I'm going to use the process called completing the squares to accomplish this. And the first thing I'm going to do is I'm going to factor the 3 from these two terms, the quadratic term and the linear term. So I will have f of x is equal to 3 times the quantity x squared plus 2x and then plus 2. Now remember, when we were completing the squares, when we have done this in the past, it's when we were trying to solve quadratic equations, which meant on the left side we had 0. However, on this problem we have f of x, which means we're really just working within one side. So normally we would move this 2 over to the left side. We're not going to do that, and it changes the process a little bit. All right. So the next thing I want to do is write this function with some blanks, because what I'd like to accomplish is complete the squares, or turn this actually into a perfect square trinomial. That's what my goal is. Now, if I'm adding something in here inside the parentheses, since I'm doing this not to both sides of the equation, but just to one side of the equation, I'm actually going to subtract it here on the outside. All right, because remember, what you with an equation, you would normally do it the same thing to both sides, but since we're now doing it to the same side, we really want to be adding 0. And if we add 0, that means we're really going to be adding and subtracting the same thing. I'll explain more about this as we go. So the process to find what is in the blank is actually the same. It's that little formula, b over 2 quantity squared. So the b in this case is 2, So 2 divided by 2 is 1. 1 squared is 1. So we have f of x is equal to 3 times x squared plus 2x plus 1 plus 2 minus, okay, I'm leaving that blank here for a second, and I want to show you something. This cannot be 1, and here's why. This value, even though this is 1, does not represent 1. You're like, what? What do you mean? Well, think about it. If I were to distribute the 3 back into my trinomial here, which I'm not going to do, but if I were to do that, what would that value be? It wouldn't be 1. So whatever that value is what I have to subtract over here. So in other words, to get that other blank, I've got to take that leading coefficient 3 and multiply it by the blank I just filled in, which is 1, to get my value of 3 here. Okay, we did that with the completing the squares process. Just wanted to remind you that we have to do that again. So now what we have is f of x is equal to 3 times x squared plus 2x plus 1, and the 2 minus the 3 happens to be negative 1 here. And so what I'm going to do now is factor the x squared plus 2x plus 1, which is x plus 1 times x plus 1 minus 1, and finally I will have 3 times x plus 1 quantity squared minus 1. Now we have vertex form, and remember the vertex is your horizontal and vertical shift, so in this case it's negative 1 comma negative 1. So remember, with the horizontal shift you have to think in terms of opposites because it's always x minus h. So if this is ever going to be positive right here, that h value has to be negative. So that's why it's a negative 1 comma negative 1. And there's your vertex. With the second problem, I'm giving you a function again in general form, but this time instead of just finding the vertex, I actually want to graph this. Well, really, in order to graph this, I need to get the most critical point of the function, which is actually the vertex. So we're really going to repeat the same process we had before and just take it a step further by graphing it. So again, I'm going to have f of x is equal to, I have to factor the negative 2 from my first two terms, the quadratic and the linear term, which is x squared, and then minus 3x plus 2. I then want to create those blanks. Remember, it's plus 2, then minus a blank. All right, and remember the same thing applies. We want to do the b over 2 quantity squared. Well, negative 3 is my b, so this will be negative 3 over 2 quantity squared, which happens to be positive 9 over 4. So I'm going to have positive 9 over 4. It is a fraction. That's okay, we can deal with that. As my first blank. Now remember, to find my other blank, I actually have to take the positive 9 over 4 times the negative 2. So by multiplying this, I'm actually going to get a negative 9 over 2. All right, so now I have f of x is equal to negative 2 times, I'm going to do two things at once here. I'm going to factor this, and this becomes x minus, 3 halves, and x minus 3 halves. And then the positive 2 minus a negative 9 halves actually turns into plus 13 over 2. Okay, so one more time, one more step, f of x is equal to negative 2 times x minus 3 halves squared plus 13 over 2. All right, so that is my vertex form. So the first thing I want to do is identify what the vertex actually is. So the vertex is 3 halves, comma, 13 halves. Now, for graphing purposes, it's a lot easier to convert this over into the decimal equivalent. So this is actually, if you're looking for a decimal, this is going to be 1.5 comma 6 0.5. Okay, so for graphing purposes, it's a little bit easier to look at it this way. Again, think of these as your horizontal shift and your vertical shift. Okay, so if I were to look at this in terms of my my original function, my most basic function. In fact, if I'm graphing this, what I'm going to actually do is start off with the most basic function, which I'm going to keep the -2, my a, and then x squared. So I'm going to go ahead and graph -2x squared, and then use the h and the k to shift it around. So if I were to graph -2x squared, I'm going to have 0, 0 as one of my ordered pairs. I'm going to have +1, -2, and -1, -2. Now, by keeping the -2 as my original function, my most basic function, I've done two things. Number one, I've actually reflected it across the x-axis, and that should have been, hopefully you recognize that you had to do that because of the negative. And the second thing I did was actually had the vertical stretch, and the vertical stretch was from the 2. So from here, what I can do to get my final answer is go ahead and shift this graph 1.5 units horizontally and 6.5 units vertically, okay, and then I have my final answer. So 1.5 units to the right, 6.5 units up, so it's about right here. That would be my vertex. And I do the same to these other two ordered pairs, these other 2 points. So again, 1.5 to the right and 6.5 up, so that's 2, 3, right about there, and we have them point right about here. Okay, and that's your final graph. So again, the vertex, to graph this, we really should A, find the vertex, B, we should graph the basic function, which we're going to include the A, whatever that A happens to be, graph that, which will take care of any stretching, it'll also take care of any reflecting, and then from there we can do any horizontal or vertical shifts using the vertex. Okay,